Hi, my name is Stephen Mogensen, and I will be talking today about Apache Storm Event Stream Processing. So first, a quick introduction to Apache Storm. So Apache Storm is a distributed stream processing computation framework. From the Apache Storm website puts it as Storm makes it easy to reliably process unbounded streams of data, doing for real-time processing what Hadoop did for batch processing. So essentially what it does is it takes in real time streams of data and it performs processing on that. It can do so in like a distributed kind of computational environment, similar to what Hadoop does for batch processing essentially. Um, so Apache Storm, the jobs in Storm are called topologies. And topology is made up of what they call spouts and bolts. So the spout is the part of the topology that kind of plugs into the incoming, the real-time data streams, and that can be from any source. In my example I'll be showing in the demo later, it's going to be plugging into the Twitter feed. So it's going to be receiving in live Twitter information from live tweets that are happening in real time, and then outputting streams of data based on that. Then the bolt is the unit that does the actual processing of the data. So a bolt reads in a stream of data, does some processing, and then it can emit a new stream of data um, that can also be then read in from another bolt, which does its own processing, and then it can emit another piece of data like that. And so you can kind of have like a whole network of these spouts and bolts kind of working together, a little bit like this diagram. So several spouts can connect to a single bolt, a spout can connect to several bolts, several bolts can connect to a single bolt, etc. So just whatever kind of architecture you need, it's able to handle that. So now I'm going to be getting into the actual demo. So I'm going to be using Apache Storm to process streams of data that are coming in from Twitter, and we're going to try to visualize the top 10 most used English language hashtags that are being used in real time. So um, let's see. So let's first start off with looking at the code. I'm just going to give a quick code overview here. So this was written in Java. Um, so each Java class represents either a spout or a bolt, as I was talking about before, and then here's the topology. So it starts off with what I call the hashtag spout, and what this spout's doing is it's plugging into the Twitter API, and it's outputting specifically all of the hashtags that it's coming across. It's not actually looking at the full tweet, it's just pulling out all of the hashtags and outputting each hashtag. And the count bolt is reading the outputs from the hashtag bolt then, and what the count bolt is doing is it's counting up all of the different hashtags it has so far come across. So it's keeping a mapping of each unique hashtag it's so far come across with and it's mapped to a number, with the number being how many of that hashtag it's so far come across. And for every hashtag it comes in, it's outputting that same hashtag followed by a number. It's outputting a tuple essentially of the hashtag and the number of that hashtag it's so far come across to the next bolt, which is the intermediate ranker. And the intermediate ranker and the total ranker are kind of working together here, and they're taking in all the information from the count bolt, and then they're the ones that are kind of calculating, right, which ones are the top, in this case it'd be top n, so I have top n over here set as 10. So here specifically we're looking at the top 10 most used hashtags that are that the count bolt is feeding them. And this 10 right here, this is the number of seconds between every time it reports to the report bolt. So the total ranker is going to be outputting every 10 seconds to the report bolt its latest findings essentially. Now of course these other bolts are outputting much more frequently. Of But finally, the report bolt is going to take in the information from the total ranker bolt, and it's going to publish that to Redis. And we're going to be using Redis to publish it to a port on localhost so we can visualize kind of in a word cloud those top 10 hashtags. So that's what the reports bolt is doing. And that is the last one. So it's just the one spout and then followed by 1, 2, 3, 4 bolts kind of like lined up in a row. And then finally there's a visualization tool down here. This is just a short Python application for running that visualization. And as I mentioned before, outputting it as kind of a word cloud. All right, so let's actually do the demonstration now. So I'm going to open up a terminal window. I'm going to navigate to the Redis folder, and the first thing to do would be to start the Redis server. So we'll do that with this command. All right, so now the Redis server is running. I'm going to just minimize that and open up a new, actually 2 new terminal windows. All right, and we'll be navigating to the, this is where I have my project in that Storm folder. So we're going to navigate into the Storm folder. This one I'm going to be navigating into the visualization folder, and I'm going to be running the visualization application from this window here. So now that's running on localhost port 5000. So if we open up a web browser, go to localhost port 5000. So this is just going to be showing real-time analytics with Storm. So there's nothing showing yet since it's not actually received any data, but once it does start to receive data, it's going to be showing in this window, and then when we look at that localhost port 5000, we're going to be seeing a word cloud of all the data it's getting in so far. So now for actually packaging the application here, we're going to package it using Maven with this command, Maven package. This will just take a quick second here. Alright, so we have build success. And if you look at this tree structure here, we'll see what Maven did. So it created this target directory with all the class files, but of particular interest is the jar file here, the top hashtags jar file. That's what we're going to be using to actually run the application. So I'm going to start off, alright, so I'm going to use storm jar, then I'm going to get that, type out that jar file name. And finally, we need to type in the name of the actual topology. So that's going to be top hashtag storm, top hashtag topology. So top hashtags dot storm dot top hashtag topology. Okay, hit enter. And this will take a little second here to get going. It produces a lot of output, as you can see. And once it starts outputting to Redis, we're going to start seeing the input in this window actually. So that's what I'm going to be waiting on. It's starting up Zookeeper there, you saw. Still doing some initialization here. Looks like it's starting up the different threads that are running the different spouts and bolts. Okay, here we go. So here's the first bit of information. So it's received, well, it's just started, so the top 10 is only have a count of 1. Okay, and then every 10 seconds it's going to receive a new top 10. So every 10 seconds it's going to get, so you should see, there we go. So now there's the latest top 10, the third top 10. Of course it's still kind of just only started running, so the most frequent one it's come across so far is only 4. So it does take a little while for it to kind of build up and to get some like reliable information on what really truly the top 10 tweets are in that moment. So I'm just going to let this run. Well, actually, before I do that, I can show on here. Now, the font on the word cloud corresponds to the number of hashtags that the program has come across so far. So right now the words are really small and you can't really read them. But after it runs for a little while, it'll look a little better. So I'm going to pause the recording now, and we're going to come back to this, and we'll see what it looks like in a little bit. All right, so this has been running for some time now. So here in this left window, this is where the Storm application is running. So all this output is just showing the the processes that are happening. So it's essentially showing the input and the output for the different bolts and the output from the spout in the application. And over here we can see every 10 seconds those top 10 hashtags being updated every 10 seconds over here. So for example, right now, so this is the top 10, the latest, this is the latest top 10 right here, and then in a second that'll probably get updated. Looks like so there it just got updated. So the top one right now is looking at 65, then there's 41 from this one, 27 tweets from that hashtag, etc. So looking at the window with the word cloud in it, so these are the top hashtags that are happening right now. And so the larger fonts are from the bigger, the more frequent hashtags. So that's why this one right here is the largest font, because that was at the top of the list there. One odd thing I'm noticing here is there's a Korean hashtag showing up here. I'm not sure why that is, because I'm in the hashtag spout, I'm only passing through hashtags that, well, at least Twitter is reporting as being English tweets. So either these are English tweets that just happen to have a Korean hashtag, or Twitter is just off with some of their tweets in terms of not quite knowing what language they're in. I'm not certain, but yeah. So this is the final product, and so thank you for listening to my presentation.